Let's make it a little bit harder now. For the parent function f of x equals 3 to the x, I want to graph k of x equals negative 3. X plus 2, I'm going to put those in parentheses just to remind myself that's the crazy cuckoo bizarro bonkers world, and then all minus 3 on the outside. All right, so this is easy for me. Home run, Svetlana victory. Just because of my high school experience with my exchange student girlfriend in my baseball career, it's easy for me to remember home run, Svetlana victory. Horizontal shift, reflections, stretches or shrinks, and then vertical shifts. Well, horizontal shift, I can see we're going to go left 2. So left 2, then reflection. Outside affects the y. A positive y becomes a negative y. That means we're going to reflect over the x-axis. Stretch or shrink, there is none. There'd be a number in front of the 3 for that. And then the vertical shift, I can see we're going to be down 3. So my parent function looks like this. Exponential growth. Why? Because the base is bigger than 1 and the exponent is positive. So I'm through this point, 0, 1, and I have 1, 3 here. And here is my y equals 0 horizontal asymptote I love so much. So let's work these transformations out. First, I'm going to go to the left 2. So 0, 1 goes to here, and 1, 3 goes to here. Let's move this one out a little bit more. So now I've got this graph here. It looks like this, and these points are, if I move this to the left 2, I'm going to be at negative 2, 1 here, and if I move this to the left 2, I'm at negative 1, 3. So my asymptote stays the same at y equals 0. So I've gone to the left 2. Now I'm going to now reflect this over the x-axis. So this point here, negative 2, 1, is now going to become negative 2, negative 1. I'm taking the opposite of the y, and negative 1, 3 becomes negative 1, negative 3. And so my asymptote stays the same at y equals 0. And I've got this point here, negative 2, negative 1, and this point here is negative 1, negative 3. So I've still got my 2 points and my 1 asymptote. And if I move everything down 3, it's going to be tough to see here. If I move this down 3, I'm going to have negative 2, negative 2, negative 4, and here, negative 1, negative 3, if I go down 3, will be negative 1, negative 6. And so my graph is going to look something like this. This is my final graph. Well, I moved down 3, so my horizontal asymptote now is y equals negative 3. So I've got my graph. It goes to the points negative 2, negative 4, negative 1, negative 6. Those are my 2 beautiful points. And the asymptote is y equals negative 3. If I follow this horizontal reflection, stretch, shrink, vertical, I never get it wrong. So how do I remember that? Home run, Svetlana, sweet Svetlana, victory. All right, one more like this. F of x equals 3 to the x. Now graph g of x equals 3 to the negative x minus 2 plus 1. Perhaps I was given this, g of x equals 3 to the negative x plus 2 plus 1. Notice what I would do. I would factor out that negative, and these two are equivalent there. But if I do it like this and I factor out the negative, it's a little bit easier for me to see the transformations. Again, home run, Svetlana victory. I'm going to go 2 to the right. So this is right 2. This is reflection. Well, this is associated with the x. And so this is going to be over the y-axis. Stretch or shrink, we don't have one. And vertically, we're going to be up 1. So if I'm graphing this, our original parent function looks like this. This is our parent function that goes through 0, 1 and 1, 3 and has this beautiful y equals 0 horizontal asymptote. So to the right 2, if I'm going to go to the right 2, then I'm going to be over here and here. If I'm to the right 2, then if this was 0, 1, now I'm at 2, 1. And if this was at 1, 3, I'm now at 3, 3. Those are my 2 points, and my graph would look something like this with this transformation. Now I'm going to reflect this over the y-axis. So 2, 1, if I'm taking the opposite of the x, puts me at negative 2, 1. I took the opposite of the x, and 3, 3 goes to negative 3, 3. And notice this horizontal asymptote stays the same. And so I've got what looks like now exponential decay. The last thing is going to move both of these up 1. So if I move everything up 1, of course, my horizontal asymptote becomes y equals 1. And negative 2, 1 becomes negative 2, 2. Negative 2, 2. And negative 3, 3 becomes negative 3, 4. Negative 3, 4. Now look what I've got in black. I've got y equals 0, and I've got negative 3, 4, and negative 2, 2. And I've got my graph. Looks like that. I've got my 2 points and 1 asymptote. I've done my job.